So today we are going to be looking at the area of a circle, which can be solved using the formula pi r squared. Let me give you an example. If we say example 1, find the area of a circle with radius. Find the area of a circle with radius, let's say 3.5 cm. Take a look at this. So we are given that pi is equal to 22/7 as we discussed yesterday. Then radius is equal to 3.5 cm. Then we have that the formula is equal to pi r squared. When we substitute this, we have 22, which is pi over 7, which is pi times 3.5 times 3. Of course, you have your cm times 3.5 cm. So remember, okay, I can simplify this because 3.5 is half of 7, right? So if I cancel it, I'll have 2 here. 3.5 is half of 7, so I can divide both of them. I have 2 here. I can also divide this, I'll have 11 here, right? So 11 times 3.5 cm, because this is cm squared, will give me 38.5 cm squared. That is it. So it's very, very simple. Whenever you want to find area of a circle, all you need to do is pi r squared. Let me just do another one. Let's say we are to find the area of a circle with radius, let's say 7 cm radius. So we have that radius is equal to 7, pi is equal to 22/7. The formula remains pi r squared, which is 22/7 times 7 times 7. Remember to add your cm, please. So 7 can cancel 7, right? Then 22 times 7, 2 times 7 is 14, so I can write 4 and carry 1. 2 times 7 again is 14 plus 1, which is 15. So cm squared. So area of a circle with radius 7 cm is 154 cm squared. Now after this, we are going to the next thing we have to do, which is have to find the area of a sector. Let me draw a sector so that you can remember what a sector looks like. A sector is a part of a circle bounded by 2 radii and an arc. And many times within this sector, you have something called theta, which is the angle between the 2 radii. Is that okay? When you have a sector, the angles between the 2 radii is what we call the theta. We call the angle between the 2 radii theta. So if you are going to find, let me solve one example for us. Let's say find the area of a sector. Find the area of a sector which subtends 90 degrees at the center and has the radius 7 cm. So we have that in this case, this theta is 90 degrees and the radius is what? 7 cm. Is that okay? The theta is 90 degrees and the radius is 7 cm. I'm going to solve it somewhere within this center. Is that okay? Let me just bring out a space to solve it. So we are given that theta is equal to 90 degrees, right? R is equal to 7 cm. Pi is equal to 22 over 7, right? What again do we need? I think we have everything that we need. Now the formula is equal to theta over 360 times pi r squared, which is the same thing as 90 over 360 times 22 over 7 times 7 times 7. Now, 0 can cancel 0. 9 can cancel 36. We have 4 here, right? 4 can cancel this. We have 11 here, right? That is 2 and 11 down here. 7 can cancel 7. So what do we have left? 11 is here, 7 is here, and then we have 2 under. So we have 11 times 7 all over 2, which will give us the same thing as 77 over 2 cm squared. 77 over 2 cm squared. If you want to simplify it further, right? Let's simplify it further. 7 divided by 2 is 3. Remainder 1. Put that 1 here. 7 divided by 2 divided by 17 is 6. 6 divided by 17 is 8. Remainder 1. 1 over 2 cm squared. So this is the answer when you want to find the area of the sector of a circle. Area of a sector of a circle which subtends 90 degrees at the center is 38 and a half cm squared. Find the radius of the circle. So this is just the question, but I twisted it in another way. So we are having here, we are given that area is of the sector is equal to 38 and a half cm squared. We're also given that theta is equal to 90 degrees, right? So we have that the formula is equal to theta over 360 times pi r squared. So this area will give us equal, that means 38 and a half cm squared is equal to theta over 360 times pi r squared, which will still give us the same thing as 90 over 360 times 22 over 7 times r squared. Is that okay? So remember, this 38 and a half is the same thing as 77 over 2, right? We can divide this and we have 4 here. 90 divided by 360 is 4 under. Let's still split. We can have 2 here and we have 11 here, right? Yes. Now, these 2 and these 2 can cancel out because they are both denominator. That means the numerators are equal. So having that already, we can have that 77 is equal to 11 times r squared all over 7. Is that okay? 11 times r squared all over 7. Sorry, I'm going to clean this part so that I can solve further. So having this already, we can say that multiplying both sides by 7, I have that 77 times 7 is equal to 11 times r squared. This will also imply that 77 times 7 all over 11 will give me something as r squared. Now, when I have this, sorry, I'm going to clean a bit further so that we'll see how it goes. So what I just did here was that I simplified. So we have, I divided by both sides by 11. So this 11 coming here will be over, right? Now 77 can cancel 11 and we have 7. It means that 7 times 7 is equal to r squared, which is the same thing as 7 squared is equal to r squared, right? So when we find the square root of both sides, we have that this will cancel this. So r is equal to 7. So the radius, when we solve it like this, will give us equal to what? 7 cm. The radius will give us equal to 7 cm. Now, take note, you're going to be solving your own assignment on this. If you have any question, you can drop it and we'll attend to it. Thank you very much.